Hello students and welcome back. In this video we will continue to discuss the topics in section 3.4. In the previous video we had just finished doing example 2 on page 169 where the problem asked us to find the number of ways of forming 4-digit codes in which none of the digits in our code can repeat themselves. Okay, and you can see how they work out the problem in the book by using the permutations formula. So in the previous video I also showed you that you can use the fundamental counting principle from section 3.1 to solve this problem. So in theory, you can actually solve the problem in both ways, either using the permutations formula or the fundamental counting principle. So it's important to understand the connection between the permutations formulas that we discussed in the previous video and the fundamental counting principle from section 3.1. Let's go ahead and go to the next page. And the next page mentions a formula for distinguishable permutations. So you'll see this type of situation where you're asked to find an arrangement of objects where some of the objects on our list repeat themselves. So for example, if you're asked to arrange the letters on this list, you notice that the letter A repeats itself 4 times, the letter B repeats itself 2 times, followed by the letter C. So if that's the case, right, if some of the objects that you're asked to arrange are repeated, then you apply the following formula. So fortunately, we're not going to discuss this. This is a topic we're going to skip over, and you won't see it in the homework. But in case you're curious, right, this is how you would calculate the number of arrangements of objects where some of the objects repeat themselves. The next topic is about what are called combinations. Right, it says here in the box that the number of combinations of R objects selected from a group of N objects without regard to the order is given by this formula here, where R is less than or equal to N. Okay, so that brings us to the definition of a combination. So a combination represents the number of ways to select R objects from N distinct objects without regard to the order in which the objects are selected. So that's the main difference between a combination and a permutation. So in a permutation, the order of the objects matters, but in a combination, the order of the objects does not matter. So R is the number of objects we select, and then N is the total number of objects we have to choose from. So R must be less than or equal to N. So the combination formula is given on page 171, but I highly recommend that you use the combinations function on your calculator rather than using the formula. Okay, so to help you understand the difference between the permutations and combinations, so for example, let's say we have the 3 objects, red, blue, and green, and we want to find the number of ways to arrange 2 of the 3 objects. Okay, so the keyword here is arrange, right? So arrange means that the order in which we take the objects matters. Okay, so for example, I can select the red and the blue objects, so red, blue. But because I want the number of arrangements of those 2 objects, okay, I would also count blue and red as separate from red and blue because the order in which they're selected is different. And likewise, I can select the red and the green objects. Okay, and count the green followed by the red object as a different arrangement of those 2 objects. And lastly, I can select the blue and the green objects. Okay, so blue green would be distinct from green blue. Okay, so in other words, we end up with 6 possibilities of selecting 2 of the objects and then finding the number of arrangements. Okay, and this is something that you can check with the permutations formula. So if we have n equal to 3 objects, we want to find the number of permutations of 2 of those objects. So using that permutations function, we have 3 NPR2, and that should give us 6. Okay, when we listed all six ways to arrange 2 of the objects. Okay, On the other hand, if we want to find the number of ways to select two of the three objects without regard to the order, right, then for example, if I select the red and the blue object first, okay, I do not need to include the possibility that I select the blue object first, followed by the red object, okay, because the order does not matter. So red-blue is the same thing as blue-red because the objects are the same. Okay. Likewise, I can select the green and the red objects. But I do not need to consider the possibility of selecting red first, followed by green. So even though these are different arrangements of these two objects, both contain the green and the red objects. Okay, likewise, the two remaining objects are blue and green. And again, because I'm just selecting them without regard to the order, I do not need to count the possibility of selecting green followed by blue. Alright, so you can quickly see that the number of ways to select two objects from 3 is equal to 3. Okay, and you can figure that out using the combinations function on your calculator, so NCR. So type the number n first, then find the combinations function, then the number of objects that you're selecting, which is R, press enter, and we see that we get 3. Okay, so I think we're ready to start the homework. Okay, so question 1 in section 3.4 says, decide if the situation involves permutations, combinations, or neither, and this says to explain your reasoning. Okay, so it says that the number of ways a 5-member committee can be chosen from 11 people. So the obvious question is, right, does the order in which the committee is selected matters? If so, it would be a permutation. If not, if the order in which we select the 5 members in the committee does matter, then it does not matter, then it would be a combination. Okay, so now that we understand the difference between permutations and combinations, let's go to look at some homework. So question 1 in section 3.4 says to decide if the situation involves permutations, combinations, or neither, and then explain your reasoning. And it says that the number of ways a five-member committee can be chosen from 11 people. So based on that description, we need to decide whether that's a permutation, combination, or neither. So if the order in which the people on the committee is selected matters, right, then it would be a permutation. If not, if the order in which the members of the committee are selected does not matter, then it would be a combination. So let's consider these 5 individuals. Let's say that Bob, Brenda, Belinda, and Bryce, and Beatrice are selected on the committee. So for example, if I rearrange the names on this list, so Bryce, Bob, Brenda, Beatrice, Belinda, right, is that still the same 5 people? And the answer is yes. Okay, so you can quickly figure out that if I rearrange the names on this list, it's still the same 5 people. It's still the same committee. So when you answer this question, right, you would select the best answer choice based on your observation. Okay, same with question 2. How many different 4-letter passwords can be formed from the letters Q, R, S, T, U, V, and W if no repetition of letters is allowed? And I think we did a problem like this in the previous video with numbers rather than letters. Okay, so I'll let you try to figure this one out on your own. Okay, question 3 says you have 9 video games. How many different ways can you arrange the games side by side on a shelf? So hopefully you have a good understanding of permutations and combinations. So this would be an example of a permutations problem, right? You're trying to find the number of different arrangements you have for these 9 different video games. So the order in which you place the video games on your shelf does matter. So this is a permutation. So since we're selecting all 9 of the video games, right, we're going to use the factorial function to answer the question. So it'd be 9 times 8 times 7 times so on and so forth all the way down to 1. Okay, or 9 factorial. Okay, and we can see that 9 factorial is 362,880. Okay, so just over 362,000 different ways that you can arrange those 9 video games on your shelf. Let's go to look at question 4. It says there are 54 runners in a race. How many ways can the runners finish first, second, and third? So you can think of this as a fundamental counting principle problem. Okay, so you have n equal to 54 runners. Okay, and then how many ways, right, can these runners come in first, second, and third? Okay, so you can think of this as r being equal to 3. Okay, so the question is, right, is this a permutation or a combination problem? Okay, and like I said earlier, right, you can probably think of this as a counting principle problem. Okay, so out of the 54 runners, right, there are 54 possibilities for first place. Okay, and then followed by 53 for second place. So once the first runner comes in first place, right, there are 53 more runners that can come in second place. Okay, so once you have the first place runner followed by the second place runner, okay, that means there are 52 more runners that can come in third place. Okay, so since this is happening in sequence, right, first place followed by second place followed by third place, right, the fundamental counting principle says you multiply these numbers together. So 54 times 53 times 52, right, should be the answer. So 54 times 53 times 52 is equal to 148,824. Okay, so in other words, close to 149,000 ways that in a race with 54 runners, right, there are that many ways that the runners can come in first, second, and third place. So before I move on, I want to mention, okay, so we can solve the problem using the fundamental counting principle. So if you look closely, right, this is actually a permutations problem. So for example, if, let's say, Bob, Bryce, and Beatrice are the first, second, and third place winners. Okay, so first, second, third place. Right, then that's different from Beatrice, Bryce, and Bob, right, coming in first, second, and third place. Right, so that's a different way that those 3 winners can come in first, second, and third place. Okay, so in other words, you can quickly figure out that the order in which the runners come in the first, second, and third place matters. So you can quickly figure out that this is a permutations problem. So you can use the permutations function on your calculator to solve the question. So with n being 54 and r being equal to 3, using the permutations function, we get the exact same answer. Okay, question 5 is very similar. So an archaeology club has 39 members. How many different ways can the club select the president, vice president, treasurer, and secretary? So figure out whether the order in which the members are selected matters, and if so, it's permutations. Okay, if not, then it'd be a combinations problem.